Welcome. Today we're diving into one of the most famous theorems in mathematics, the Pythagoras theorem. This theorem is a cornerstone of geometry and has been used for centuries to solve problems involving right-angled triangles. Whether you're a student, a math enthusiast, or just curious, understanding this theorem will open up a world of possibilities in measurement, construction, and even navigation. Let's start by exploring what the Pythagoras theorem is and why it's so important in both academic and real-world settings. Theorem is named after Pythagoras, an ancient Greek mathematician and philosopher who lived around 570–495 BCE. Pythagoras and his followers, known as the Pythagoreans, made significant contributions to mathematics, especially in understanding the relationship between numbers and shapes. While the theorem was known in other cultures before Pythagoras, he's credited with providing one of the earliest proofs. His work laid the foundation for much of modern mathematics, and his theorem remains a vital tool in geometry today. Before we get into the theorem itself, let's clarify what a right-angled triangle is. A right-angled triangle is a triangle where one of the angles measures exactly 90 degrees. The side opposite this right angle is called the hypotenuse, and it's always the longest side. The other two sides are referred to as the legs of the triangle. Understanding these parts is crucial because the Pythagoras theorem specifically applies to right-angled triangles and helps us relate the lengths of their side. Now let's state the Pythagoras theorem clearly. In a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. In mathematical terms, if a and b are the lengths of the legs and c is the hypotenuse, then a 2 plus b2 equals c2. This simple yet powerful equation allows us to find the length of any side if we know the other two, making it incredibly useful in various applications. Better understand the Pythagoras theorem, let's visualize it. Imagine a right-angled triangle with squares drawn on each of its three sides. The area of the square on the hypotenuse is exactly equal to the combined areas of the squares on the other two sides. This visual representation helps make sense of the equation and shows why the relationship holds true. It's a powerful way to see the connection between geometry and algebra. Let's apply the Pythagoras theorem with a simple example. Suppose you have a right-angled triangle where one leg is 3 units long and the other is 4 units. To find the hypotenuse, we use the formula. 32 plus 42 equals c2. That's 9 plus 16 equals 25, so c2 equals 25. Taking the square root, we find c equals 5. This example shows how the theorem helps us calculate unknown side lengths quickly and accurately. Pythagoras theorem isn't just for textbooks, it's used in real life every day. Architects use it to ensure buildings are constructed accurately. Surveyors rely on it to measure distances that are hard to reach directly. Even in navigation, the theorem helps calculate the shortest path between 2 points. From construction sites to computer graphics, the Pythagoras theorem is a practical tool that makes complex measurements simple. While the Pythagoras theorem is powerful, it's important to remember that it only applies to right-angled triangles. Trying to use it with other types of triangles will lead to incorrect results. Another common misconception is confusing the hypotenuse with the other sides. Always ensure you're working with a right angle and correctly identifying the hypotenuse before applying the theorem. Wrap up, the Pythagoras theorem is a fundamental concept in mathematics that connects geometry and algebra. It allows us to solve countless problems involving right-angled triangles both in theory and in practice. By understanding and applying this theorem, you gain a valuable tool for academic success and everyday problem solving. Keep exploring, and you'll find the Pythagoras theorem at the heart of many mathematical adventures.